Inside the world's largest building, an extremely complicated maneuver is underway. So far, the Dash 8 team has built her wings and her fuselage. Now it's time to bring it all together. To make this Dash 8 look like a jumbo. Joining up the three sections of the fuselage is one of the most demanding jobs in the entire assembly process, which is why it's done in the dead of night. It's safer, fewer people on the floor, less chance of something going wrong. With millions of dollars worth of aircraft parts coming together, this is an extremely delicate industrial dance. The ground crew have to pay attention to the smallest details. The crew are positioning the forward section to receive the wings. When lowering a section, the team must be precise.
To line up to make sure that we set in the cradle at the right position. It's a matter of quarter inch either way.
The wings are now joined to the center fuselage. They span almost the entire width of the factory floor. Two tractors must pull at exactly the same speed to stop the wing section from veering off into the sides of the factory. The clearance between the walls and the wing tips is just 5 centimeters. Next, the tail section joins up with the rest of the plane. The characteristic jumbo outline is taking shape. She's 76 meters long and 68 meters across. Thousands of hands have got the aircraft to this stage. The task of managing and organizing such a large crew isn't easy. But it's something Boeing has had plenty of practice at over the last 40 years. During the early years, Boeing faced a financial meltdown. It came close to bankruptcy. There were layoffs and pressure to halt development. Running the 747 program was a real challenge.
We were working very hard to get all of the drawings out at that time, so the engineering department was peaking out at about 4,500 people. I was asked to make a big cut in that. We needed 800 more engineers. I think maybe I'm going to lose my job today, but I'm going to tell them the way I see it. I figured that was when I did the best job I could have for Boeing. If I had reduced the engineering force, the whole program could have tumbled.
The latest jumbo jet program also has the potential to tumble. In 2008, Boeing's machinists go on strike for 2 months, throwing an already tight schedule into disarray. Each day lost costs Boeing $100 million. Added to the wing engineering issues, Boeing is forced to delay delivery by 2 years. Some buyers cancel their orders. But Boeing's immediate concern is to finish this one. It's time to give her some power. Time for the new engines, 4 revolutionary ones. The old 747 engines consume over 12,000 liters of fuel per hour. With oil prices at an all-time high, airlines are seeking any way to minimize fuel consumption. Finding a more efficient engine is critical to the Dash 8's success. General Electric is at the forefront of jet engine design. These brand new engines are the most efficient they have ever made. Boeing challenged GE to adapt them for the new 747. But they don't come cheap. With a list price of $20 million each, these engines are the new jumbo's single most expensive component. But they are worth every cent. Composite materials used in the fan blades and casing trim 180 kilograms from each engine. Multiply that by 4, and it equals almost 10 extra passengers. And with fewer fan blades and lower turning speeds, these are the quietest engines GE has ever made. They can push through more air with less work. And that means burning less fuel. So how do they do that? Only 10% of the air is mixed with fuel and burnt in the combustion chamber, driving a series of turbines that power the big fan at the front. And that's the fan which pushes the other 90% of the air out the back of the engine, creating thrust. Despite burning less fuel, 4 of them can propel a fully laden 747-8 at over 1,000 kilometers per hour. Just one of these engines creates as much thrust as all 8 engines on a B-52. Back at the factory, it's time to hang the engines. Massive concrete blocks hang on the wings where the engines will go. Without them, the aeroplane would tip back on its tail. Each engine weighs 7 tons, and there are 4 engines to get off their trolleys and onto the wings. That's like hanging 4 bull elephants. It's a job to do slowly and carefully.
Let me put a little tension on it and test it.
If the 4 winches are slightly misaligned, it won't go in square, and they're in trouble.
45. Got your wheels where you want them?
Our team's a pretty tight unit. We work together fairly well. We all have our positions on the plane that we like.
0.
All right, start pulling your pins. Yep. We communicate well together this way. Keeps us from getting into any troubles. Harness up for safety.
For safety.
We're about 12 inches away. We're going to pull the bolts from the front fitting. There's a pin up front that lines up the forward mount. So we lube that up with anti-seize. We'll come up another 6 inches, make sure everything is clear. Then we'll come up the last 6 inches and then put all 4 bolts in. Very close tolerance, within a thousandth of an inch. Come on up.
It only takes 8 bolts to hang these massive engines.
All 4 started, all grabbing.
Here you go, 50%.
Not yet. I'm still getting these down, Axel.
Okay. The torque on those bolts are 625 foot-pounds on the rear, 375 foot-pounds on the front. The fronts are designed to shear off. That's per design, and that's in case there is any problems that the engine will shear at the front, fall back, and break away from the plane without taking out wings or flaps or any of that. There's one.
There are 3 more engines to mount. Once again, the crew will need to burn the midnight oil to get the job done. After weeks of painstaking work, it's almost time to switch the beast on. But first, there's more painstaking work. Every circuit needs to be checked, one by one. This plane uses a lot of electricity, enough to power over 50 households. 214 kilometers of wiring runs through the aircraft. It all converges in the electronics bay. It's the plane's nervous system. The new fly-by-wire technology is controlled by onboard computers. But it's not totally automated. The pilot can override the computer. and there are multiple layers of backup if something should go wrong.
If I were to lower the flaps, it takes hydraulic systems to do that. But if for some reason the hydraulics were unavailable, we could use the air or pneumatic air pressure to lower the flaps. If that was unavailable, we could use electricity to lower the flaps. So there's multiple layers of redundancy.
Technicians use a special computer to send a test signal to every single circuit.
Second rigger 10495. On.
Okay, Kilo 2.
Bravo 24 and Bravo 21. Off.
The moment of truth. Time to plug in the factory power supply and fire her up for the first time. Power on is a key moment in completing a Dash 8. With engines in place, this jumbo is almost ready to take to the skies. But first, she needs an interior. Like the GENX engines and wings, her new interior is borrowed from her little sister, the Dreamliner. There's new colors, more space, and mood lighting. Boeing customers have their own idea of interior design. Each wants their jumbo painted in their colors, inside and out. In the mega factory's huge paint shop, the green protective vinyl is washed off. A base layer is sprayed on by hand, followed by several coats of color, depending on the customer's livery. They need to be careful with the number of layers they apply. Too much paint could mask telltale signs of metal fatigue. And besides, the extra weight of more paint would only increase fuel consumption. A typical paint job uses 500 kilos of paint. It will last 4 years. This one is painted in Boeing's own colors because it's time to put her through her paces. She must undergo a series of grueling test flights before delivery. Test pilots push the plane to extremes that will never be endured by its passengers, unless they work for Boeing.
Give it up, Asia, for your favorite doctor. Brady Barr is in your town.